Ever wondered what happens when you flip a light switch? It seems so simple, right? But behind that instantaneous burst of light is an incredible journey, a massive, complex, and fascinating system that brings electricity right to your fingertips. Today, we are going to demystify this modern marvel and trace the path of an electron from its creation all the way to your home. So, grab a snack, get comfortable, and let's unravel the epic journey of electricity. It all starts at a power plant. This is where the magic begins, where energy is converted from one form into electrical energy. Power plants come in many shapes and sizes. You have thermal power plants that burn fossil fuels like coal, natural gas, or oil to heat water and create steam. This high-pressure steam then spins a massive fan-like object called a turbine. Imagine a giant, incredibly powerful pinwheel. Then there are nuclear power plants, which use nuclear fission, the splitting of atoms, to generate immense heat, which also creates steam to spin a turbine. And of course, we have renewable sources. Hydropower plants use the force of falling water from a dam to spin their turbines. Wind farms use, well, wind to turn their giant blades, which are connected to turbines. And solar farms use photovoltaic cells to directly convert sunlight into electricity, a process that doesn't even need a turbine. No matter the source, be it steam from burning coal, a nuclear reaction, or the force of wind, the goal is the same: to get that turbine spinning. Why? Because that turbine is connected to a generator. And a generator is the real powerhouse here. It's essentially a massive collection of magnets and copper wire coils. As the turbine spins the generator, it rapidly moves the magnets past the coils of wire. This movement creates a magnetic field that excites the electrons in the copper wire, forcing them to move. And the movement of electrons is what we call electricity and electrical current. So, we've generated electricity. But this electricity isn't ready for a cross-country trip just yet. The electricity coming out of the generator is at a relatively low voltage. To send it over long distances efficiently, we need to crank up that voltage a lot. Think of it like water pressure in a hose. If you want to spray water a long way, you need high pressure. It's the same with electricity. Higher voltage means less energy is lost as heat along the power lines. This is where the first major stop on our journey comes in, the step-up transformer, located right at the power plant. This device, as its name suggests, steps up the voltage from a few thousand volts to hundreds of thousands of volts, sometimes up to 765,000 volts. It's like putting the electricity on a super-fast, non-stop express train. Now, our high-voltage electricity is ready to travel. It leaves the power plant and enters the transmission grid. These are the giant metal towers you see striding across the countryside, carrying thick, heavy cables. These are the superhighways of the electrical world. They transport enormous amounts of power over hundreds of miles, connecting power plants to entire cities and regions. This interconnected network is crucial because it ensures a reliable supply. If one power plant goes offline, electricity can be rerouted from another part of the grid to prevent a blackout. It's a beautifully coordinated dance of supply and demand happening in real time, 24/7. But of course, you can't plug your phone charger into a 500,000-volt line. That would be explosive. So, as the electricity gets closer to your town or city, it needs to be stepped down to a safer, more manageable voltage. This happens at a power substation. You've probably seen these fenced-off areas with lots of complex-looking equipment and buzzing sounds. Inside, there are step-down transformers. These do the exact opposite of the transformers at the power plant. They take the super high voltage from the transmission lines and reduce it significantly, maybe down to around 10,000 volts. From the substation, the electricity continues its journey on what are called distribution lines. These are the smaller, more common power lines you see running along streets, either on wooden poles or buried underground. They carry this medium voltage electricity throughout your neighborhood, like smaller roads branching off a major highway. These lines bring the power much closer to its final destination. We're on the home stretch now, but 10,000 volts is still way too much for your home appliances. So, one final transformation is needed, Look around your neighborhood. You might see a gray, can-shaped transformer mounted on a utility pole, or a green metal box sitting on the ground in someone's yard. These are the final step-down transformers. They take the medium voltage power from the local distribution lines and convert it down to the standard voltage used in our homes in the US. That's typically 240 volts. This 240-volt service is then split. It enters your house through what is called a service drop, a thick cable running from the pole to the side of your house. It goes directly into your electric meter, which measures how much electricity you're using. And from the meter, it flows into your main electrical panel, or breaker box. This is the command center of your home's electrical system. Inside, you'll find all the circuit breakers. Each breaker is a safety switch that controls the flow of electricity to different parts of your house: the kitchen, the bedrooms, the living room lights. If you ever try to run your microwave, toaster, and coffee maker all at once and the power suddenly cuts out, that's a circuit breaker doing its job, preventing the circuit from overloading and potentially causing a fire. From the breaker panel, wires run through your walls to every outlet, switch, and light fixture in your home. And finally, when you flip that switch, you complete the circuit. The electrons, having traveled hundreds of miles from a power plant, through transformers and substations, and along miles of cable, finally rush through the filament of your light bulb, causing it to heat up and glow. The journey is complete. And it all happens at nearly the speed of light. It's an incredible system, a delicate balance of generation, transmission, and distribution that we so often take for granted. From the massive turbines at the power plant to the tiny wires inside your walls, every component plays a vital role in powering our modern world. The next time you turn on a light, maybe you'll think about that amazing journey and the incredible engineering that makes it all possible. Thank you so much for joining me on this electrifying adventure. If you found this interesting, don't forget to hit that like button, subscribe for more deep dives into how our world works, and ring that notification bell. Let me know in the comments what other everyday marvels you'd like to explore. Thanks for watching, and see you in the next one.